This example comes out of section 1.5. The section is called velocity and other rates of change, and this one has to do with some kind of raw data we're given here in a table where as time goes on, we're given a bunch of temperatures, and the temperature appears to be falling. It starts at about room temperature, 20 degrees Celsius, at time equals 0, and then it falls steadily over the next 5 seconds down to a temperature of 5.3 degrees Celsius. So we're going to be asked to do two things. This will be the only times we'll be asked to do this by hand. So first of all, the first one is find the average rate of change of temperature with respect to time over the interval 1 to 3 seconds, and that's just a straight find rate of change secant line kind of question, so we'll do that in a second. Second part is the one I'm talking about where we won't probably be asked to do this very often because we have to literally graph the points and manually draw a tangent line. Let's start with the first one. Change in temperature over change in time from 3 seconds to 1 second. The temperature at 3 seconds is 6.5 degrees Celsius. Temperature at 1 second is 12 degrees Celsius. So if you subtract those, you find that this thing has dropped. In other words, negative 5.5 degrees Celsius is my change in temperature. 2 seconds is my change in time. Negative 5.5 divided by 2 gives me negative 2.75 degrees Celsius per second. So it's a rate, it's not a velocity this time. We've been talking about questions that were all velocity and speed and meters per second type stuff. This one is a rate of change, but it's a rate of change as temperature changes with respect to time. So basically it's saying whether that this temperature is dropping at this to 2.75 degrees Celsius per second. Now the second one, we have to do a bit of work to set up this graph. So plotting the points, I have something looking like this, and again it's not graph paper, so it's not perfect. But if I attempt to somewhat smoothly connect the data points that I have, the point that I'm interested in is at time equals 1 second, this point right here. And basically what I'm looking for is the slope of the tangent line at that point. So if you have a ruler, you want to take out a ruler and draw yourself the best tangent line you can that comes along and touches your curve at that point. Now this is clearly, in my case, going to be very approximate. Basically I'm finding the rise overrun of that line. So if you draw the line long enough that you can find a change in temperature over change in time. In this case, it's instantaneous. It's a tangent line, but I'm looking at roughly from about just over 2 seconds. So let's make it 2.1 seconds. Is this point over here down to maybe 0.2 seconds are my two times. Now my temperature, it ends up at about 4 degrees Celsius, and it started off at very close to 16 degrees Celsius. So I'm looking at a drop of 12 degrees Celsius, negative 12, divided by 1.9 seconds. So you can grab a calculator and figure out what negative 12 degrees Celsius divided by 1.9 seconds is, and you're looking at a little bit more than 6 degrees Celsius per second. Negative 6.3 degrees Celsius per second is approximately my instantaneous rate of change at time equals 1 second. Now when I taught this one in class, I had a concerned student ask me how accurate these answers needed to be. Basically, if I can see that you're doing it right, you've drawn a curve, you've attempted to draw an accurate tangent to that curve, and you've correctly found the slope of the tangent that you drew. The actual answer here isn't particularly important. I wouldn't care if somebody had negative 5, negative 7, degrees Celsius per second. Obviously, if somebody had a positive answer or an answer that was way out to lunch, negative 100 degrees Celsius per minute, it would be clear that they had done it wrong.